Hello, this is Brother Cromer from the Math Department at BYU, Idaho, and these videos are covering Lesson 22, which is dealing with describing bivariate data, scatterplots, correlation, and covariance. So here's the outline for these videos. First, I'll discuss scatterplots, followed up by correlation coefficient. Then we'll cover form, direction, and strength, and we'll be using these first two items here, scatterplot and correlation, to determine form, direction, and strength. Then I'll talk about covariance, followed up by effects of outliers, and then wrapping it up with nonlinear relationships. So first, let's talk about a scatter plot. So here's a definition of a scatter plot. So a scatter plot or scatter diagram displays a relationship between two quantitative variables that are measured on the same individuals. So you mark the values of one variable on the horizontal axis and the value of the other on the vertical axis, and then you plot the individual data as a point on the graph. So here's an example of what you might see, or two examples of scatter plots. So let me describe this information here. First, the one on the left represents the relationship between powerboat registrations in Florida and manatee killed. So each point here represents a given year where what was measured is the powerboat registration in Florida for a given year and the number of manatee killed in the waters. And so what you see here is that as the powerboat registrations go up in Florida, more manatee are killed. And so this is an example called a positive relationship between two variables here, okay? Meaning as one variable goes up, so does the other variable as well too. Now the one on the right represents, in terms of, if you wanted to go to cars.com, you could see Toyota Siennas or whatever cars you want to buy. And here's an example where we wanted to look to see the relationship between the mileage of a car already driven and the price of the car that's on the lot. And so if you notice here, for instance, is that, so for a given car, there's a certain point. In this case, the mileage was about 70,000 miles and a price of about $11,000 to $12,000. But as you notice here in this situation, is that as the mileage of the car that's been driven goes up, then the price of the car decreases. And so this is an example of a negative relationship. Okay. So now what I want to do is talk about the correlation coefficient. Let me expand this a little bit here. So the correlation is a calculation to determine the strength and direction of a linear relationship only. It can't be any other type of relationship, but just a linear relationship between two quantitative variables. So the correlation R is always a number between -1 and 1. These are the boundaries. Now when it comes to the direction, okay, positive values of R imply a positive linear relationship between two variables, and negative values of R imply a negative linear relationship between two variables. So items 2 through 3 generally cover the direction of a relationship, positive or negative. Now 4 through 7, mostly it's covering what's called strength of a relationship, though there's a little bit of direction. So values of R close to 0 suggest there's a weak correlation between the two variables. R close to 1, it is evident that there's a strong positive linear relationship between the two variables. R close to -1, there is evidence of a strong negative linear relationship between the two variables. And then if R is equal to 1 or -1, it seldom happens, but it can happen, then there is a perfect linear relationship between the two variables. The points are all on the line. So the correlation, so basically all these things are covering the strength of relationship. Numbers close to 1 or -1 means a strong relationship, and then numbers close to 0 means a weak relationship. So the last item here from 1 through 8 is that the correlation of x and y is the same as the correlation between y and x. There's no distinction between explanatory and response variables. These two explanatory and response variables I will cover in the next lesson, or we will cover in the next lesson. Now correlation is not resistant to outliers. Okay, so outliers can greatly change the value of R. Do you remember what other measures that were not not resistant to outliers? Well, there was a couple. The two that stand out is the x bar, the sample mean, or a mean, and the standard deviation. Those two are not resistant to outliers. In fact, how you calculate the correlation uses primarily standard deviations. So since those standard deviations are not resistant to outliers, then the whole thing, R, is also not resistant to outliers. So what we need to do is we need to examine the outliers and determine their influence on the relationship between x and y. And lastly on this slide, the correlation coefficient R is a sample statistic. Now do you remember other sample statistics? One is x bar, which is the sample mean, so that's a measure from a sample, as well as the sample standard deviation. And it is an estimate of the population correlation coefficient, which we will denote as the Greek letter rho. Usually we do not know rho or the population correlation coefficient. Okay. So now let's talk about, now here's an example of SPSS output. You can get similar output in Excel as well. But this here represents, for instance, with manatee killed versus number of powerboat registrations per year. We get a correlation coefficient of 0.952, which is pretty high. So going back to the definitions, this is going to be a very strong positive relationship. Now with the car data, we get a negative value of negative 0.868. So that means it's negative, fairly strong relationship between price and mileage. Okay. So when we put it all together, form, direction, and strength, we can use scatter plots as well as the correlation coefficient. So examining scatter plot and correlation, 3 items to look for. Form. We primarily with this look for linear relationships, so you can look for other relationships, where the points show a straight line pattern and are an important form of relationship between two variables. Curved relationships is another form to watch for, but for this course we're primarily interested in linear relationships. The direction has a clear direction. We speak of either a positive association or positive relationship or negative association. And strength is determined by how close the points are to a scatter plot line. And we also look for outliers and other deviations from the pattern. So now here's basic diagrams or basic scatter plots. So here we can look for the form, direction, and strength here. So if this is a scatter plot and here's the correlation, well, the form is nonlinear. Direction, well, there's no direction, and the strength is very weak. So you can stop the video and you can do these other ones, and then I'll go through them with you. So the correlation here, the form is perhaps nonlinear, but the direction is negative because we have a negative correlation, and the strength is weak, still fairly weak. Now over here on the right, the form it's getting to be linear. Direction is positive, and the strength is more moderate than anything else. Now on the bottom left, the form is starting to look linear. Direction is negative, and then the strength is getting to be it's fairly strong. Over here, the form is linear, the direction is positive, and the strength is getting strong. And then the form on the bottom right one, the form is linear, definitely linear. The direction is negative, and the strength is very strong, Superman strong. Now, some students ask, well, how do you tell between linear, nonlinear, weak, moderate, strong? Well, there's no set guidelines, but hopefully you can see that there is a general, it's a continuum, if you will, but looking at these scatter plots, you can see get an idea about the continuum. Okay. So now, looking at form, direction, and strength with the data that we've looked at here, we have a correlation of 0.952, and here's the scatter plot. So we can see here that the form is linear, the direction is definitely positive, and the strength is pretty strong. Okay, and the dots are pretty darn close to the line here for to create a line. The correlation over here on the right, it's negative 0.868. Again, the scatter plot. We see that basically that the form is linear, the direction is negative, and the strength is fairly strong. Okay, so I'm going to stop the recording here. I'm going to continue with the remaining part of the dealing with covariance, effective outliers, and nonlinear relationships in part 2 of the videos.